Hello everyone, and welcome to the second and penultimate episode of Solar Architecture Voices. I'm really happy to have you all here today for this session entirely dedicated to architecture this time. And our guest for today is Jean Didier, architect and founder of SOLARCHITECTURE Studio, and actually a true expert in the field of solar architecture, of course. As always, the structure of our episode will be the same. So we have the first part, more or less 20 minutes with the presentation of the topic of the day. And after this presentation, there's other 20 minutes entirely dedicated to your questions. So once again, you can start writing them in the chat. You can direct the questions to me, on to Jean Didier, but it's better to me. And during the time related to the question, I make sure to pass them everything to our guest. So actually, I think I can hand over the presentation to Jean Didier, and we can start the today episode.
Yes, indeed. So can you see the screen?
Not yet. Now, yes, we can.
And can you see it changing? Yes. So, yes, my name is Jean Didier. Thank you, Greta, for the introduction. I will try to do a 20 minutes overview of 15 years of work, which will be a bit of a challenge. But the idea today is not to see too many different projects, but probably to try to understand what are the challenges that we face as an office in solar architecture. So mainly what I want to explain at first is that we work in urban and peri-urban contexts with the goal of 2050. And basically, we want to update those cities, those European cities or abroad. But we have as many different projects as the typology of buildings that exist. So it's a bit sometimes lots of different configurations and demands. And of course, when you look at the map of a typical city, European city, here, for instance, the city of Paris, you understand that the update that we want to do of the existing city, because we don't want to dismantle and make only new buildings, we work a lot on existing buildings, but a lot of them are very old, and sometimes even heritage buildings. If you see the map here, for instance, all that is from light blue to dark blue has about 1 century, is 1 century old. But those projects are being updated as well. This graph is to illustrate that sometimes that field of architectural photovoltaics is perhaps too quickly reduced to the PV glass. If you look on the web, if you go to fairs, you will see a lot of new technologies, new PV silicon technologies, ways of coloring these technologies. But what we encounter here in our practice is way different, because we have the same challenges as an architectural office, which is architecture and urbanism, project engineering, how to bring those to the site, how to build a crane that will build those structures on top of the buildings, and the system engineering, the complete system engineering, which is much more than PV glass, because we are talking about steelwork, DC cabling, sometimes curtain walling on the facade. So it's much more than PV glass that probably takes just 20% of our time. So this is what I want to illustrate as systems. So we try to design not only the PV glass itself, but also how it's held and how it's talking with the facades or with the fifth facade, the roof that we will equip. Here you have some close details of a project from Renzo Piano at first, where you can see that trying to put the DC cabling into that structure was really demanding. The second one is the Médiathèque de Saint-Malo in the north of France, where we needed to have that angle that was changing every line to respect the shape of the architects. And the last one is the French Ministry of Defense that was, of course, very protected, and where no cleaning machine could be going on top. So we have built a scale 1 demonstrator showing that we could cut into a PV panel and probably make cleaning access via that gate. So much more than just the PV. And what we receive from the architects on our table every month has been evolving these last 15 years. First, we were, of course, in application, and this is what we don't want anymore. We don't want a bluish PV panel on a terracotta roof. This is quite obvious now. Then we switched to BIPV, which is really substitution. We encounter that glass could be waterproof, could be a protection. So the 2.0 is really the attitude to give an additional function to this PV, which is being completely into the skin of the building and having that function. And then the 3.0 that we encounter today are those optimization. So it's a shape that has been optimized for the solar function, meaning that the angle, the tilt, the azimuth has been chosen directly for that function. That's what we call urban solar farm, which to me is extremely interesting because it is assuming the solar quality of shape. So this is the end for the pure theory. I think it's always better to talk about projects and real life projects. I will begin with what we call fifth facade. So globally, it's the position of a roof, but that really looks like or is designed like a fifth facade. The first project that I wanted to show you is UNESCO context solar projects. So of course, in the city of Bruges, in the north of Belgium, completely into a UNESCO context, you cannot put any PV on any kind of roof. But the architects who had won the context of the Brusque Museum for Arts decided to propose a project that was zero energy. And they did the opposite. They designed a shape that was completely solar, south-facing with a certain angle, a bit like a wing. So the project is a mix of a new building with BIPV roofs and existing building. That's the shed that you see on the side where we have put classic PV. But still, the aim was that we could not feel that those roofs were made with a PV material because of that UNESCO context. So the idea of Robrecht and Dam architects was to have a tile that was dark green and with a certain materiality, a 3D graining that would make it look like something else, like a skin. So as explained, when we did our irradiation, it's a dream simulation because it's pure south and with a perfect tilt. But the idea was different. The challenge was to have that shape that was a bit like a wavy glass, a bit like a snake skin, and with a dark green color. So at the very last moment of the contest, when the architects were only 2 teams left, we quickly went to a producer of BIPV, and we managed to make a 400 millimeters sample that has been used in the context of the contest of architecture. And globally, this is what we had designed with our CAD modeler. Because we wanted to be sure of that fixation. You see that The glass was a challenge because it was a wavy glass, what we call cathedral glass, like ancient glazing. The color was a challenge because we didn't want it to lose output due to the color. And of course, the system was a challenge because on some point you had unframed laminated glazing with 4 layers of glass in the same point. So it was very important to study it and see how external elements like wind was operating. So this is the result. More than the fifth facade, we also equipped the lateral roofs and also the pure facades, the vertical ones. And I think we are not too far from what we expected. And at the end of the day, I think the performance is perhaps more the detailing, that aluminum extrusion making possible to have that overlap, quadruple overlap on the glass, than the glass itself. I think we see both in the architectural language, and that's what we are very proud of. And we spend a lot more time on the detail than on the glass itself. So to show you another example of the fifth facade, we had the chance to work in 2022 with Jean Nouvel Architects in Paris. And here the challenge was to have a golden PV on top of the tower because the facade, the curtain walling was already equipped with a golden glass. So at the end of the day, we needed to match a RAL color, or more precisely a NCIS color, to be exactly the same as the top of the tower. It took 4 years actually to please the architect with the right color. I think we have proposed approximately all the existing coloring techniques available. And at the end of the day, we ended up with that pixelization of the glass on top of a very classical monocrystalline PV cell. And here you see the final result as at a certain distance. You see that I think the contract was respected because we really feel that the fifth facade, the roof, is talking directly with the facade, and even the top crane, the equipment has been tinted in the same color. But what perhaps could be improved was that the angle of the roof itself is not south-facing at all. So sometimes I think we focus perhaps too quick on things like color, and perhaps not on the form finding itself when we talk about such projects. So that's for what we call the fifth facade, the roofing, and of course we have some projects in facade itself. And this is our very first project for Renzo Piano Architects in Paris, which is called TGI, Tribunal de Grande Instance, but that's mainly the Great Tribunal of Paris. And that project is a solar machine that has been made vertical. You see on the blueprints that it is a multi-layer facade. There is an inner glass and then an outer glass, and then we came as a third layer in front of the facade with, to me, the APV, so applied photovoltaics, next to the facade, with that kind of wing flying on top of the first facade. And here again, we had only one glass type to be repeated all around the tower. So it was not so complicated to produce that rectangle with PV cells. What was very complicated was to put it at 160 meters high with the wind conditions in Paris, and to follow that detail that has been designed by Renzo Piano and by our teams, with those tubes, both horizontal and vertical, that were holding the whole system. And of course, the diameter of the vertical tubes that were taking the DC cables was very narrow and was really designed on our prescription. So, so the idea was to really verify where to put the MC4 connectors and how to be able to maintain that afterwards. And the system that we have now is that the David, so the system that is used for cleaning the facade, goes at the back of that system, and you can rotate the lower PV to make it accessible and get the junction boxes. So that was not so easy, but it's always, of course, a great challenge and great pleasure to work with such architects. At some point, you have to announce that, yeah, that glass at 160 meters high will not be held frameless with 4 hooks. That's not possible. So we had to ask for peripheral aluminum frame. So that was a piece of discussion with the architect. But at the end of the day, we found a great design for that framing. And I know that the architects are very happy with that final design. It is completely part now of the identity of that project, because if you take the peripheral highway in Paris at night, you will see that only the PV structure is backlit by a LED installation at night. And I think, yeah, it's very light. And so I think it's important to also illustrate that you don't always need to have tinted glazing or strange shapes or curved things to make something optimum. Here, I think again, it's the detail itself that is visible more than the glass itself. And during the work site, we had to send some alpinists to try to sort electrical problems. That's what we don't want during the lifetime of the project. Lots of time we hear that yeah, we are talking about optimizers on facades and a lot of electronic devices directly on high buildings. That's really something that we prefer not to do. We want to bring all the intelligence of such a project into an accessible place, like a technical room into the building. And we prefer to work with a stringing layout more than bringing intelligence directly on the PV glass itself, because it means that you bring an additional risk on the facade, and maintenance at 160 meters high is not the same price as just sending a technician to a inverter room. So that's very important for us, the maintenance. And this is how it looks delivered. So another project is World Trade Center. I called it top of the class because in Brussels, it has that small tower is really an example, not solar-wise, but on all topics of what the Belgian government wants us to do as architects with the existing buildings and how to update the city for 2050 objectives. And more than the PV glass, these are example of the PV glazing that we have proposed and finally installed on the tower. The global project was really ambitious because these towers were existing from the 70s, and the architects decided to remove all the facades, but to keep the concrete core of the building. So the dismantling of that building was not 100%. It was probably 70%. And by reusing the slabs and the core of the building, they won a lot of equivalent CO2. So the whole building was really ambitious. And on our side, we were asked to put some shadow profiles, BIPV, all around the new facades, and we were working for the facade engineering team. The big challenge was to make everything invisible. So here you see a typical section that we had produced with Kiotech facade. And you see that all the DC cabling goes into a vertical profile extruded, and that takes exactly the maximum diameter of the MC4 connector. So we are very proud that now today those shadow profiles are, let's say, yeah, you can identify their solar aspects due to the PV cell, but you can't see any kind of cabling, nowhere. It's all included in the facade profile. And that was the biggest part of the work. And this is how it looks like today. Actually, at some point of the project, they have added another PV part, which is what you see on the right. That's the greenhouse, and the greenhouse is a glass box with a park inside it that is accessible to the public. So that's a public space that is offered by the project to the community. The thing is that it's a lot lower than the World Trade Center tower, so it is completely under shadow. So we had to discuss a lot with the owner, asking if that horizontal roof was really something we were willing to equip, but they really wanted to have a BIPV at that place. And what we found after some simulation is that actually the irradiation level was not so bad, and that's just due to the mirroring of the other towers next to it. So actually, even though it's a bit northern, etc., we have at some point good curve just linked to the mirroring effect of the other curtain walling next to the project. So here you have a bit of both projects, the facade one with all the shadow profiles that are completely participating to the internal comfort and the level of cooling that is brought to the building. So it really brings shadow. And also the detail of the greenhouse that is more classical shape of PV, so with a certain tilt and a certain space between the glass. And then that last chapter is about the solar structure. So that's the 3.0 that I shown at the beginning of the presentation. And here we'll show you some nice projects of architects willing to do expressive solar. So not something that is following the facade, but something expressive. Here, for instance, La Scène Musicale. So that's the main concert hall now in Paris. It is on the Seine, like an island in the middle of the Seine. And that project is a bit, yeah, that's something very well known in Paris because a lot of architects have proposed projects on that island, and only Shigeru Ban really, I think, showed some or presented something very convincing, which is that kind of a concrete building that is surrounded by a park, and even the roof is completely walkable and accessible, and it is a park mixing art and vegetal. But he also has designed that kind of an egg, and it is in that egg that is the main concert hall. You can see it in the sections and plans. The whole structure is, yeah, a bit the signature of Shigeru Ban Europe. It is a mesh of wood, but he also wanted to have that sail that is literally physically turning around the project, and that is a mix of glass and PV. He wanted to have Japanese beetle. So at first we didn't really understood what the architects meant by that. But after showing the animal, we understood that Japanese beetle has really some very uncommon colors. It's a bit like irradiation colors, and that is why the architects wanted to have that sparkling green, very typical of polycrystalline PV. That at the end we were able to provide. And of course, that sail participates also to the internal comfort because it's following the sun. but we are completely conscious also that it is a piece of art and a demonstrator as well as a solar device. Another project that is not so far is the Dominique Perrault Poste du Louvre. I call the title Gambling in Paris because the architect said during the contest, while they were still in the architectural contest, that he would go higher than the Haussmannian Code in Paris. And that Haussmannian Code, the urbanism of Paris, giving maximum height for the roof, is really something that you can't discuss with. It's really compulsory to follow that code. But he said, I'm not doing any roof. I'm making a solar machine. And that's at the end of the day how he won the project. And he asked Sensok how to define that walk around. So it is really a place that you can use for walking on top of a hotel. And the idea was to have both a park and a PV collector on top of that very heritage protected building, because it's very well known by the Parisian people. That's the head of the post in France, that is open 24 hours a day, etc. That was the first idea of the project, to really have a park and something walkable plus the solar function. I think it's interesting because we experience a lot that pressure on the roof of recent projects where we want to have both HVAC, greening, and solar collection. Here, I think by lifting it up and putting people under that canopy, we could do both. We could do a bit of greening and solar collection. And this is how it is today. I know that they build a very nice rooftop bar also that is now very well known in Paris. But you are literally into surrounded by those PV elements, but that are not completely closed. It's 50% opening, and that's, I think, what contributes to the lightness, to the light effect of the whole structure. And you can see that, very nice view on Notre Dame, and on the other side on the Eiffel Tower. Probably that's the typical solar machine. The first time that we used that word was working with Renzo Piano on the CERN Science Gateway building in Geneva. So it is the very well-known CERN complex, the particle accelerator that is well-known in Switzerland. But because that site is really closed and not accessible to the public, the CERN asked the architects to have a science gateway building, meaning a hub where students and people willing to visit could have an access and explanation on the process of the CERN. So it has been materialized by 3 pavilions, and those 3 pavilions have received on top the solar collector that is again completely separated on its own structure and designed as a different piece of architecture than the building that is under it. And again, the solar is very repetitive. It is rectangular blocks. We only gave to it a white fritting on the back of the glass, because that's an architecture that has to be seen from the public space, so from the back of the glass. But otherwise, it's just a rectangle with 20 millimeters of gap between the cells. But the system on how to hold it and how to make it elegant, to me, is the real performance. So you see that now with just that small fitting, that white fitting at the back of the cell, we have a complete different perception of the global project, because the white elements at the back of the cell is the same white element as the structure and as the cladding. And what I prefer probably is the game of those shadows under the canopy. Renzo Piano itself had a very nice word about that. He called that a komorebi, which is a Japanese word that express the good aspect and the feeling that you have when you walk under a tree with the shadow of the leaves. And he wanted to build kind of artificial leaves on that project with that komorebi effect. So these structures are very typical from Renzo Piano architecture. We have received many projects like the CERN project, and today we are still busy working on the Kyklos Art Center in Athens, where again, yes, you have that the main building and an additional layer on top of that fifth facade that is completely solar. Even though here the typology is a little bit different because the roof is closer. But again, yeah, we like to give it an expression. And so smaller project is that flying carpet in Brussels. I like this project because it is very very accessible. It's a private owner who came to see us in 2017, and he decided to make an architectural contest about that project that you see in the center. That's a building from the 70s that was really suffering in the very center of Brussels of too much identities around it, because you had the biggest city mall of the city next to it. You have one of the oldest hotels. You had the Sheraton Hotel on top, the Dexia Tower, and the big circular structure from Laurent, which is the entrance of the main metro station in Brussels. So no one could see that building, even though it was extremely central. And because the owner was a retailer, he really needed to give that project a new identity. And the brief of the contest was to put that old building in the new century using renewables and renewable energy, and also giving it a new identity. So our proposal and how we won the contest was to just put an additional crown and really a different object on top of the building with an inverted slope, because the main facade is north facing, so we could not make a facade, a vertical facade, or even something like a bubble on top of that building, because the orientation was not proper. So we had to invert the curve, making it south facing, and also we have equipped vertically an invisible wall that is completely south facing. So that's the project at the permitting phase, and you see that the challenge was really important in terms of structural engineering, because we brought a lot of extra loads on the four corners of the building, and we wanted to give the impression that the PV was flying between those two structural elements, the front and the back one. And doing so, we used a structure that is in pure tension, really working as a cable, and slightly curved. So the detail of the steelwork and how to put the glass on top of something slightly curved like this was really the number one challenge on that project. And the company who delivered this worked a lot with us to improve the framing and that rotating detail that we had to use. Of course, bringing such a huge structure in the very center of Brussels, we are just a few meters away from the Grand Place, was a huge challenge, and the whole structure has been delivered and mounted in only one night, because we had only one night to cut the whole avenue that was next to the building. And this is how it looks now. I'm very proud of that project also, because that's one of our signature. That's a project directly from us as architects from Sunsoak, and I think that that's one of the projects that people understand directly because of that angle that is south facing. It is very clear that we do not look at a canopy or something non-active, because otherwise it would have a completely different shape, and that shape is really completely solar oriented. And probably the best thing on the project is what you see a bit on the left, is the shadow that is brought on the steel, the steel plate, the white steel plates. They have a lot of shadow games that changes with the seasons. And also we really wanted to leave an open gap between the existing and our intervention, so that it's completely understandable that we talk about something new today. So that's what we are now, and we are very happy now to work on other projects like this structure that is still under tendering, but that is also in the center of Brussels, with the challenge that it is the only recent architecture that will be visible from the Grand Place. So we are very proud to have received the approval from the City Council about that, and this is the one that will be our near future for the next month to come. It's to build that kind of small forest on top of an existing 2,000 buildings, again to operate the update of the city of Brussels. Voilà, that's it for me.
Thank you, Jean-Didier, for your explanation and for this amazing presentation. So I just checked the chat and I can't see any questions till now. So I'll give you maybe a couple of minutes. So you have to direct the questions to me, so Supsi Isaac. And after that, I'm gonna read everything and we are gonna have these sharing moments to uncover your doubts or your questions or your curiosity. So I'll give you a couple of minutes. Feel free to put everything in the chat. So we have one first question, sorry. And the question is, how do you convince stakeholders that aesthetics and energy performance can coexist without compromise?
That's the biggest question that we have constantly in our table also. So that's a very good one. I think that some of the stakeholders are already willing to make such interventions, both aesthetic and operational, on their buildings, like we had Bota Solar, so the first project in Brussels. And here we had to make no effort for that. But the project that you have on the screen here, for instance, is completely different. We were in front of a retailer here who really needed to update that building, even though it's not so old. But we had to convince him not to put just PV on top of that tower, because that's a completely different attitude with the building. So what we use to convince them is to explain that the return on such an investment is not only based on solar kilowatt hours incentives. It is playing with something different, which is the image of the building. And when we talk about the image of the building, it's also the price on the real estate market, the value of that building on the real estate market. So not to talk too much about image, here it's something completely measurable to see that before and after the solar intervention, the rent of the square meters on that building has been increased, and that waiting for clients, the length of the wait has been decreased. So it's something very tangible and really measurable. That new identity is something that helps the owner on his sales and his rents, and the value, the real estate value of that building.
So thank you so much for the answer. In the meantime, it came up another question. So how do cultural differences across regions influence the way solar is integrated into architecture?
That's probably the part that I prefer, is the interaction with the cities and with the building councils. And that's very true that culturally we have a lot of differences. Sometimes it's a bit bizarre that the north of Europe and Germany and Paris have so many wheels about solar, even though we are not solar lands and we don't receive a lot of irradiation here. But we see bubbles actually. We see small zones in Europe and abroad, also in the US coasts and in Middle East. So some places where probably culturally people have made that step forward about solar. We know that in Monaco, for instance, where we had 3 or 4 nice projects, it is under the will of the prince himself to build solar structures, but also because it's a city that lives a lot about the fifth facade, because when you arrive to Monaco, you see all the buildings from the top. So they wanted to have a very nice fifth facade. In Paris, it's a little bit more a game of architects and star architects looking to each other, and when one begins with one type of intervention, well, you receive a lot others. But when you look at Middle East, for instance, like the city of Masdar that has been designed and delivered by Foster and Partners, that's completely cultural, and that's probably the most interesting project. The way that Masdar PV has been designed like a moucharabieh on top of the narrow streets, and also how the Middle East today understands that they have to change their model from previous energy to the next generation. To me, it's extremely impressive. And yes, of course, we have to deal with all those cultures and approaches, and how the city councils in the different cities of Europe and abroad understand our projects. But that's the part that I prefer, because we learn a lot from those cities.
Thanks again. So we have a really curious question. So do you have any project where aesthetic integration failed, and what was learned from this experience? So it could be a yes or no.
I want to be honest. It's not 100%. We had some projects where we were not happy with the aesthetics. Yes, that's true. Of course, that's not the majority. So I want to ensure people about that. But yes, actually, our small office does not receive the projects on the pre-design phase systematically. Sometimes we arrive very late on the project, and that's the project that we fear the most, because most of the design decisions are already taken, and sometimes the building permits are already granted. So we arrive more like technicians, and we are just asked to put a golden color somewhere, and that's it. And that's where sometimes the mistake happens, because you end up with a zone that is vertical, with trees on top, with the interior of a building. So you have a lot of shadows, and people are completely concentrated on the RAL color of the PV elements. But to me, that's not a good attitude, because it's first form finding that you have to do to understand if it is or if it is not solar. And then only if you could answer yes, that face is irradiated enough and you don't have any shadow and it is the right orientation and tilt for what you need to do with that solar, with the producing curve, then afterwards you can give it a color. But yeah, some projects were not so good due to that approach that was a bit of mismatch. Yeah, of how should a nice PV project happen.
Okay. So right now we don't have any questions left. So if everything it's clear or don't you have any other curiosity, I think that we can close here the episode, and I want to thanks again Jean Didier for this amazing presentation. So